All right.
Now we can start. So, thanks everyone for being there. So a little bit about me, and then will be about the functional optics. So my name is Juliette. I go by she, her. I've graduated both in mathematics and in linguistics, and I have a very diverse life story. Usually when I'm on stage is to recite poetry, but I'll try to spare you tonight. But you know, sometimes poetry just happens and we can't stop it. I'm volunteering in a trans financial literacy organization. I'm helping the team to organize their collaboration around IT tools. My main languages are Lua, Go, and TypeScript. Sometimes I play with Haskell, C, C++. My last position was at LUCAM in a small research group, and I'm currently working at
If you're right, Haskell, you know Samuel, so surely, right?
No.
You don't know him.
He's not in the manual. It's not going well tonight. I'll take a mouse.
How about emergency?
Yeah, that's...
You always have one in your backpack?
Inside my shirt.
Okay, so I don't have a job, so if you have...
like this?
Yeah, I cannot center it with keyboard. It was super easy to do.
Turn in a sticker as well.
You should make bad like this.
So if you have the feeling... if you have the feeling that would be a good match, please let's talk. Now about lenses. So talking with a few of you before the presentation, I noticed that for some people thought it was just about functional programming as a general approach. Optics is really a specific concept, and lenses are the most common case of that concept, and it's what I'll be going to talk about. It has like lots of theoretical groundings, but you don't need to possess all that theory to use it. So my approach tonight will be really hands-up. We will build from trivial, boring case, and we'll handle more and more complex situation. And hopefully by the end of the talk, you'll have basic knowledge of what's lens and optics, and if you try to use it, if you read documentation, it will be cleaner. So it's been a while that I'm vaguely aware that those exist, and then I code and I'm seeing the patterns in the code and I never do it. And a few months ago I've decided to give it a try, and because I was in a code base where it was a great fit, and I just saw so much complexity disappear. I saw my code become way more readable, and it was quite satisfactory. So the problem, I have a very, very simple sample code. So we have a very tiny state in a hook, and we have a handler that just updates a button that updates the value. So nothing too frightening. What are the issues? And we'll have to be over dramatic because of course it's, you don't need to come to a talk to handle that code. But let's put ourselves in a very dramatic situation. There's ... hell. You have to type, you know where it can go. When the state gets more and more nested, it's never difficult, but it's annoying. Second thing, there's an implicit coupling. By this, I mean that here you get a value, here you set what is conceptually the same thing. So when it's more complex, it's really easy to update one of these and forget to update the other one. And there's also a lack of intentionality. By this, I mean that we want to say it's about that specific field, so it's written, but it's written nowhere. So what can we do about this? Zoom, you want it to be bigger?
Yes, zooming, sorry.
Yeah, the thing is, I need to see also some of it. Yeah, I'm sorry,
No problem.
You lose the breath.
Yeah, that's it. Yeah, it will. I would.
It's okay. It's
Yeah.
good.
So, I had a
Come closer.
Yeah, I did.
little bit of formatting issue. Okay, sorry, it's MDX. So I'm extracting here. It's really a simple refactoring. So this function, this will be our first lens. So what does it do? It takes a key parameter, so it would be lolly, and it returns some kind of very simple object with two functions. First function takes a structure and returns the value it points to. So if you implement it here, you have that lens that points, that focus to the field lolly. So if we send that object, we will get 3. And so it's a getter. And there's a setter as impressive as the getter that just, you take a new value, let's say 4, you give the structure, and it updates the value in a non-destructive way, meaning it doesn't update in place, it creates a new object. What's nice is we've collocated already these two ideas of setting and getting a value. Sometimes it's called, the getter are called view, setter sometimes is called update. Other thing, I don't know if you're familiar with that style of coding, so we could just have a function that takes 2 parameters, but instead there's a function that accepts a parameter, returns a new function that accepts another parameter. So it's called querying. Functional programmers do it all the time. Most lens libraries I'm aware of do it, and we'll see later on why it's quite handy. So here we got our new code. So you have that object that is focusing toward the field, and so we just use it here to check that the state has already this value or not, and then later on we use it to update. So as you may know, setState can either accept a value or a function that updates the value.
Yeah.
So that's what we're doing here. That's where the querying is really nice. So because we have done this, we put it's a button that updates to a fixed value. So we give the value as a parameter to the component, and then we get a function that we can just directly pass to setState, and we're done. So just very very extraordinary interaction. You have the state. We have this button that's set to state. Would it work? Extraordinary. I know you're all super impressed. Like you were all waiting as your job to learn how to update a value.
I'm actually a fan of the number 5, so
Oh,
this is a
great.
big win for me.
And also, yeah. So we're focusing on fields conceptually that correspond to a product type. Product type is this idea that we're creating an object with smaller objects. So you have like in JavaScript, like you have an object with a field which is a string and a field with a number. Then it's the product type of string and number. So lengths are all about product types. So axioms of lengths. Functional programmers like to have this very algebraic approach to things. So a length is anything that respects these axioms. So these are quite intuitive. So get after set. Basically, you have some length and a state. You set a value to something. You get a value. It will be what you have set it to. Quite trivial. It works the other way around too. So you get a value from some complex object. You set it back to that value. It should not change the object. And set after set, you set a value to an object. You set a different value to the result, and it should be the same as setting the second value directly. So you kind of understand this intuitively. It's just a formalization of your intuition. And set after set can be specialized to just idempotency, meaning you set twice to the same value. It's the same thing as if you set it once. If you're using property-based testing, I think axioms is like suggesting you how to test the length. Okay, nested state. A way more complex problem. Now you have the same object, but there's nest inside. What are we gonna do? And we have twice as much dots. That's really that hell. It's starting to boil. Desperation. Desperate no more. We have composition for you. So we have the same exact length generator, let's call it that way, but we have a way to compose. So we take two lenses and we end up with a new lens. So composing the getter is quite trivial. We take the object, we apply the first getter and then the second getter, and so think about the concrete example we have. It's just checking the value of a field, and it's an object, so we check the other field. And we can compose the update part too. It's not that complicated. It's just awkward to read. You have the object, the outer object, you get the value, and you use that to set the reverse. Anyways, you get it. It's the kind of thing that you can think by yourself. And so here we have our new lens. It's quite trivially we compose two field accessor. That's it. It's the only change we have to the code. And demonstration. Will it work?
5 is bad. 5.
Woo! So it's and also the composition of two lens is a lens, which means it respects the axioms. If you feel like writing proof about computer programs, you could write proof that given those two axioms, etc. Okay. Maybe we want, instead of just changing the field to a fixed value, we want to increase the number. Ooh. So we need a third method. Sometimes it's called Assoc, sometimes it's called modify over. We could call it map because it really feels like you're mapping a functor. But anyways, I'll keep with Assoc because it's what I've seen the most. So very simply, you give a function, you give an object, and it applies the function to, not to the whole object, to the focus of this object. So if you have, for example, a lens pointing to a field, it gets the field, applies the value, updates object in place. Yeah. So, and now we can have like, we create the lens for a state, and then we can have a menu sufficient button that does +1. Woo! It's working. Extraordinary. So right now, it's even bigger than I thought it would be. So right now, Assoc is really derived from get and set. You might think it's always the case. We will see other kinds of optics where it's not the case anymore. Yeah, I won't go too far into polymorphic lenses, but with this example, you can imagine that it doesn't modify the type of the object, but you could, lens libraries also sometimes deal with the case where you have a function that modify and that changes the typing of the object. So it's called polymorphic lenses. It's not a basic use case, but just in case you see that someday. Okay. Until now, the only lens we have seen was reflecting pretty trivially the way the object is constructed. It needs not to be the case. So I'll give you an example where it's not the case. So where is this state? So we have, it's quite often the case, we have a state which is an array of strings. But semantically, we're really meaning a set. What we care about is whether a string is or is not part of it. So with get we have, here is a simple checkbox. So it will be checked if the corresponding string is in the array, and it won't be checked if it's not there. So otherwise stated, the checkbox wants a boolean, but the application state has an array of string. Who's going to reconcile them? A lens. So that's where. So what do we do? Very simply, there's a key, and we check whether it's an element or not. And as for the setter, so part will be true or false. like we give the name of a key. So we give the object, it's true if the key is there, false if it's not there. And the other way around, if it's true, then we just add the key to the object. And if it's false, we filter it away. And we'll update it with simply a function that negates. Will it work? I'm so nervous right now. Boom. And again. Have you noticed something? Who's very attentive?
Push it at the end.
You don't have a label for the,
What?
You don't have a label for the checkbox.
Oh no, that's but the state.
Yeah, Fleming moved from the middle to the end.
Yeah, exactly. So does it respect the lens laws? I think not.
No, it's not important.
Yeah. So it's changing the order of elements. So strictly speaking, set after set is not respected. Is it a lens? What do we do when we have this kind of situation? We change the rules. So the point is, we're really meaning some kind of set represented as an array. So yes, it's not equal, but it's semantically equivalent as much as we care in that program. So I've written equals, but you can think equivalent instead. And what is equivalent? It depends of your program. It depends of your concept. You have to document and communicate. I know it's painful. Okay, ISO. So ISO is another kind of optics. So it's isomorphism, but friend and family call them ISO. You have an API or a widget that uses temperature in Fahrenheit, and you have a state which has temperature in Celsius. Or how are you going to deal with this? So we have the same lens constructor, composition, and now I hadn't planned to use a mouse. And here we have that lens which we call an ISO. So formatting has been misbehaving. It's supposed to be a product. Sorry for this. So Celsius temperature gets converted in Fahrenheit. Fahrenheit gets converted in Celsius. Therefore, that parameter here is dummy. We don't really use it. That's what we call an ISO, is a lens where for the setter, the whole object is not relevant. So we same composition rule. Really, we do the same thing. We have two callbacks. And will it work? You have temp state in Celsius. And we see that state is always in international system, but widget is in whatever unit we want it. So, as some of you might remember, in 1999, NASA lost a space probe near Mars because Lockheed Martin engineers were using imperial system and they were using international system. They should have seen my talk. So if you're composing a lens with an ISO, it just gives a lens. ISO with a lens is a lens, but if you compose two ISO, it's still an ISO because in both cases the second parameter has not been used. In some libraries you have extra methods for ISO. That's right now it's just a conceptual thing, but sometimes it's relevant. Okay, just a small thing here. It's another example of a lens. What it does, it's split according to some character and it joins them back. So you could, for example, manipulate all the words, but does this suggest you something? Think of the query string of a URL. So I think it's some context where it applies pretty well, synchronizing your state with a query string URL. Lens are there for that. That's here another very simple lens. Takes a number, takes a boolean and gives a number, 1 for true, 0 for false. Takes a number and gives you back a boolean. So depending of what query builder you're using, like if you have a SQLite database and you have to store a boolean, you need to convert back and forth between numbers and boolean. Like it's all cumulative. The point is like all those things are simple, but you can compose them all together to deal very elegantly and very homogeneously with complex situations. Prism. Now we have something pretty different. So, string to number. Point is, if you take a string and want to get a number, it won't work all the time. Sometimes a string doesn't cast to a number. So backward is kind of looks like an ISO, but forward it's what we can call a partial functions, meaning that sometimes it doesn't give a result. So there's an error in the reading, in the getter. Errors can be represented in different ways. So here it's represented by undefined. You could represent it by throwing an exception. Don't do that, I'm just exhaustive. You could represent it with a tag union, and some lens libraries will do this. So there's also Assoc method is still existing. We might like you have a string to them and you want to double the number. If it's an invalid number, it won't do anything. We might not think of it as a feeder because it's some kind of mapping function. Writing the setters always succeed. So the getter might fail, but the setter, if you say I want the string that corresponds to 39, success all the time. So there's this asymmetry. It corresponds to a sum type, meaning that you can have Prism say part of a sum type. Say you have something that is either a number or a boolean. You could have a Prism that casted to either undefined or a number, if it's a number, or either a boolean or undefined if it's a boolean. So as you might have seen, like it's sort of like an ISO because second parameter, the writer is independent here, like same as ISO. And that is because ISO is both a lens and a prism. So, like, yeah. Oh, I don't have a keyboard. Okay. So, you have to trust me. It works. Okay, thank you. Thank you. So, just a few examples of prism. So, a predicate. So, for example, we could have a prism to tell whether a number is positive. So, if instead of returning true or false, if the number is positive, it returns the number, and if it's not positive, it returns undefined. And the other way around, it's just an identity function because a positive number is a number. So for the sake of simplicity, here I'm not typing anything, but you could use Prism to do a type guard. So I've given an example, and that means you can build, you can do complex validation with Prism, and you have a special way of composing Prism. And you take an object of Prism and you receive a prism of objects, meaning something that is, say, undefined if one of these fails. And optional. So that's the we'll go faster on the other types of lens, but I wanted to be more detailed on the 4 basic lenses. So So really an index, you take the nth value of an array. So it returns it, or it updates it in place. So yeah. In an optional, the reading can fail, just as in a lens, but writing can also fail. So the point of an optional is really to be able to combine lenses. So if you take, I'll get to there. So that's what we were talking about. So if, for example, we combine a lens and a prism, you get an optional. Lens and an ISO lens. So it's always the closest ancestor. So I'll give you a few, we have some ground to cover, but I'll just give you a quick example of the meanings of the other optics. So here is my very simple object. I was expecting to see both things. So an example of a getter would be, in my object, number of cats, in the sense that there's no way you can set the number of cats to far. We would have to have the information. So it's a setter that doesn't correspond to a getter. And why would you want such a trivial thing to be wrapped in an optics? You want it because you can compose it. So affine false. So it's something that focus on 1 or 0 value. So the longest cat's name. So if it's empty, it fails. If not, it gets the longest name. And here again, you cannot set the value. It doesn't make sense. So setters, meaning what would be a setter without getter? Quite often what I've met is updating 2 parts of the states. It's not really focusing two-way because there's no cohesion in it, but it's super useful in concrete code bases, like you close a widget and you focus your main interest towards something. They don't really compose as lenses, but they do compose just as ordinary function. And finally, multiple focus. So you have special lenses that focus on 0 or 1 or many values. So for example, you could write a lens that returns the 2 longest cat's name. That's a little bit far-fetched for an example. This one is read-only, but you can also write to multiple value. So name of all cats starting with the M, you can write to that. So here with my example, Marmalade, Profunctor, and Minou are the names of the 3 cats. If we set it to Matu, well, quite trivial. I mean, I'm sure you can do the mental calculation. But what if instead we update? Let's say we append Minou to all the names. Then only the cat's names that started with an M are updated because the lens is focusing on those, but they don't have the same value. So that we couldn't use a getter and a setter to derive it. That's what I had premised earlier on. So implementations. So of course you can see lens as a pattern, meaning if for some reason you cannot have another dependency to your library, you can just write simple 10 lines of code utility and your code might look really cleaner. Then if you do a little bit of research on GitHub, you will find tons of lens library in JavaScript from like 5 years ago and older, I'd say. The thing is, TypeScript really ruined the fun. If you try to implement a lens library, you'll see that runtime is super easy to get. What's more complicated is the typing. And it's also super difficult to just add types to those old library and make the inference works properly. So Ramda do support lenses. Nothing about Ramda. It's super well made, but it's just like pre-TypeScript era, so you won't have the best experience. And it's only about lens. You don't have all the other optics. There's still like treasures of wisdom about lenses, so sometimes I look at old libraries of that era just to have some inspiration about how to use them. So Grammarly has done something specific to React. Cycle.js is a old framework that never really cut, but that lenses were central to its conception. So most importantly, modern library. Optics.ts is by far the most popular. it's a little heavy on the compiler. I really see my IDE slowing down. It's bad. I found some bugs in type system. It was false positive, meaning error when it was valid. But I've never found false negative, meaning it don't accept code that it shouldn't accept. So to me that's good enough. It's sometimes the TypeScript I get a warning that it got cut in an infinite loop. So that's really intense TypeScript, but it works. You have monof.ts that you see a lot. It's a part of a Scala library with the same name. So it's unmaintained but kind of really stable. I think don't have much personal experience with it, but it makes sense. By the same author, there's FP.ts, which this one is more active, but it's missing folds and traversal, so it's still quite usable. And IOTS, maybe some of you have heard about it as a validator library, as an alternative to Zod and the like. And that's this wording that I first got. And when I opened the docs, I was a little bit perplexed because it really doesn't work like Zod. But if you think of it as a Prism library, it makes way more sense. So it's a very specialized optics library. And it's also open when you know it's really an optics library. If you're, for example, using optics TS and IOTS, you can really wrap IO into optics and have something that works well together. So, and React integrations. So what's nice is that it really fits into the model of React because immutability. It works. It's super simple. Like you've seen this example. It's super simple to use it with plain hooks. Jotai has an official library to support optics TS. But I've used mostly Zostand if you want. It's the official documentation refers to optics TS just as a useful, fancy setter library. It's way more than this, as I hope you more understand. So I won't go too much into this, but there is a section, predicates with no star actions in the official Zostand library. It gives you some inspiration, and I'm just quickly showing you the code. So, like, it's super trivial code. It's just some hooks to. I'll put the slide on the group if you want to look at it more thoroughly. But basically, I take a hook that's just create to manage a star, and you can apply the right methods. It's really super fun to use. So what are alternatives to lenses? Well, you know them, like proxy solutions. So trade-off is tools are easier to understand. Workflow is implicit. I don't think it's a good thing. But it really covers like the 2 first slides maybe 3 first slides of that talk, meaning all those fancy things like having 2 different units of measurement, turning membership into Boolean. You don't have this. What are the complements? By this I mean what problems are not solved by lenses. So lens is really about specialty, meaning a structure, and time is very simple. There is before and after. So it might be complemented with libraries that are tools to deal with complex evolution in time. So for example, RX or StateX, those are both libraries address evolution in time. Well, React hooks are a great way to address evolution in time. So, as an example, some of you know what is a Konami code, it was a cheat code in old Nintendo. That's an example of something that some state management that you don't do with lenses. And yeah, concluding remark. What I really like about lens, first, it's try and tested and theoretized. Like, I'm definitely not making this up. Like, there's been lots of reflection and experimentation. You have similar lens libraries in all languages you can think of. Like, yes, you have it in Haskell and Scala, but like, you have it in Go. It's not just, it comes from functional programming, but really it has spilled everywhere. So yeah, it's a shared language across frameworks. So all the examples are with React, but there's nothing which is tightly coupled with React. And I would conclude by saying that optics are really like sirens, and functional programming is really like sirens, because like sometimes you get so much caught in the formal beauty of it that you forget to just solve the actual problem. Beware. Thank you. So I've been behaving mostly like a getter, but now it's time to behave like a lens. Meaning, do you have questions?
I tremendously appreciate your how you say implementation of functionality, composition, the prisms, the lenses in React, but in other functional programming in functional programming languages, there's a significant compactification of the code. I don't see that in what you presented here, at least not to my knowledge.
Yeah.
What is the advantage that you're obtaining here? Is it purely structural, or is there actually a compile time advantage?
No. Definitely, like for compacting code, yes, it definitely happens. Like maybe I should have given an example of that. Like I really was trying to focus on the concepts, and so yeah, good point that it didn't show that. As for speed, there's a trade-off. It's actually slower. So you'll have two kinds of overheads. First, creating the lenses will take some time. So you try to do it outside of the component tree, or if you have to do it inside, you have to use a use memo or something. But there will still be an overhead, of course, because you're not directly updating. But it's really about making the code simpler and more maintainable, because if you change the focus, if you rename the field, for example, then you don't forget to rename the field in the update and in the getting.
There's still one redeeming feature, and correct me if I'm wrong, if you use macros, you can probably reproduce many of the structural advantages of functional programming languages. And you can create pipes, and you can.
Okay, if the question is about functional programming in general, then I guess I won't enter into the debate, but Scala has macros, and they have a lens library. They definitely want both, and they do use macros to build tests and to build lenses. So they use both together. But like, I'm not a seasoned Scala programmer.
So far we lose that in React, but it should be recoverable, should not be. And that would give tremendous optionality for a React program.
So yeah,
using Redux.
That's getting a little bit far from optics.
I apologize.
Yeah, no problem. Does anybody has a question about optics? But thanks for opening the question. That was really appreciated.
I really like the fact that you mentioned that RxJS and like can be sometimes a siren, that it kind of attracts you because it like looks so good that you kind of go into it even though you actually don't need it. And we've all met like functional programming advocates that are like everything should be functional programming, which I think you were pretty balanced that it's not always the case. Do you have like a go-to example of like one thing you should use lens for? Like I think some of your examples were like quite simple, but is there like a functionality or something that you're like, this is like the perfect example of what you use lens for?
So I had this widget that was basically building a query to some kind of database. So you would check and uncheck things, and you would enter values and fields, and that had to be synchronized with a query that was complex query object that was then passed to a filter value. It was a case where it was really, like you spoke about compacting the code, it was spectacular how that code compacted.
Because we kind of use something similar exactly for filtering. I think it's a good example. I think the other one that we also use it for work is like a rule engine. So you're trying to build like a rule engine that has like a lot of different options, a lot of different value types that you can compare also. And I think those are like good example of like how to use it.
So you use lens at work?
Well, like it's we don't use lens or optics, but we've remade the similar like polymorphism like thing, right? So you can say like, oh, when it's not this and this or this, you know, you can kind of compile these into like a single rule. And
yeah, well, lens has a pattern. Like it's, if you don't use a library, you can still use it to think about your code.
I was using a database called Juliette, and it has a peer review that it looked very similar to what you use. I was just wondering if you know any kind of platforms of your library that kind of apart what you mentioned, like if you know that this is the concept, and just I could bring a real life example of things that I use it. Why is the concept of lens?
You mean a database library that uses?
So I use this database called predicates.
Yeah.
And to do queries as you said, it's kind of exactly what you said. The question is, do you know any kind of well-known tool that we use that you are sure that it is the same concept?
Okay, well, it's really about when you use. To me, it's really about, in that case, about filling the gap between ORM and a query builder. So sometimes you don't want to go full-fledged ORM, because if you use a ORM, then you won't feel like it will do that kind of transformation in its own idiomatic way. But if you like, what's the name? I'm missing the name, but like those basic, very simple query builder, if you want to make them usable, that's where you would put, you would bring a lens library to the mix.
I see, like, but you cannot say like, oh, that database actually it really implements this pattern? What do you?
Oh, well,
That's the question.
yeah, I'm actually avoiding libraries that I really want my lens library to be uncoupled from my application library. For example, there are a few state management library that use the concept of lens, and there is one for React. I don't remember the name, and I chose not to name it because, to me, the point is to use the same lens library with your database and with your state and in a full stack application, and also the fact that the lens library is detached, it's testable. You can build fancy lens and test against it. Where if it's all tight with like database access or with state management, you still can test it, but you have to build mock and such. It's the fact that you have a separated lens library, to me, adds way more value, and you can reuse the knowledge in very different scenarios.